So here's the technical definition for radians. It's the standard unit of angle measure, and it's based on the arc lengths of the unit circle. Well, what's a unit circle? Thanks for asking. Let me clarify. Here's a unit circle. That was a messed up circle, but let's go with it. A unit circle has a radius of 1. That's why it's a unit circle. So the radius here equals 1. So knowing that the radius equals 1, we can call this a unit circle, as I have said. But the measurement of any angle in radians is equivalent to the length of the arc. For example, this angle right here. I don't know how big it is, but if I'm going to measure it in radians on a unit circle, then it's going to be equivalent to whatever that is. So, the entire circle, all the way around, is going to be the length all the way around the circle. Well, the distance all the way around the circle is given by this formula right here. I hope that looks familiar. That's circumference. So basically, the measurement of a circle, the number of degrees in a circle, the number of radians in a circle, is going to equal that distance all the way around. I'm going somewhere with this. It's a little cloudy so far, but I'm going somewhere. 2 times pi times the radius, and the radius is 1. So the circumference of my circle is 2 pi. Okay, here's where I'm really going. In any circle, I have 360 degrees. And I also have, all the way around the circle, I have this much of a circumference, which is equivalent to 2 pi radians. Long story short, in a circle, you have this many degrees, you have this many radians. The measurement of an angle can be given in degrees or in radians. Normally in radians, it involves the number pi, which we will leave as a symbol, and we will not use 3.14159 because it's an approximation. So I can have an angle that's like that. That, of course, is a straight angle. It goes across like this. That makes half of a circle. An entire circle would be that much. So half of 2 pi would be pi radians. The measurement of that angle is pi radians, also known as 180 degrees. Okay, let's do another one. The measurement of this angle is 90 degrees. Well, clearly, it's half of this last example. It's half of a 180 degree angle. Well, half of 180 degrees is 90. Half of pi is, now don't grab your calculator, don't give me a decimal. Half of pi is really just half of pi. It's pi over 2 radians. So when you've wondered in your calculator about how the calculator is figuring out angles based on radians and what are radians, this is it. Radians are based on the circumference of the unit circle, and it's really based on the length of that arc. Now, if it's still a little bit cloudy for you, that's okay. We're going somewhere with this. But we're going to have to keep this little piece in mind right here. That 360 degrees is equivalent to 2 pi radians. And while we're at it, let's write another one. 180 degrees is equivalent to pi radians. Okay? Okay, so the next thing on your paper says how to convert from degrees to radians and how to convert from radians to degrees. We're going to use that right there. I'm going to erase everything else. You might still be a little bit fuzzy on what all this means, but hopefully it's about to come together for you. And let's erase that. We'll put it up at the top. Knowing that 180 degrees is equal to pi radians, And again, don't go turning that into 3.141592653. Don't go there. Don't go there. Just write the letter pi. What we're going to do is convert from degrees to radians. So on the part where it says how to convert from degrees to radians. Okay, if I'm going to turn something from degrees to radians, I'm going to need a pi. So to do this, I will multiply by pi, and I need to get rid of the 180, so I'm going to divide by 180. On the other part, it says, how do you convert from radians to degrees? To convert from radians to degrees, we need to do basically the opposite, the reciprocal. We need to multiply by 180 over pi. So let me give you a couple examples that are not down there at the bottom. I'll let you work on those on your own. Although I do need to correct number 9 through 14. So we'll fix that in a minute. Let's do one that says, let's convert from 150 degrees, and we want to turn it into radians. We're going to multiply by pi over 180. So basically the question would say something like, what is 150 degrees in radians? Here it goes. 150 degrees times pi over 180. Don't type it in your calculator. Don't even go there. Not yet. We know our answer is going to have a pi in it. We also know that that's 150 over 180. Okay? We just multiplied straight across. It's not cross multiplication, but it's multiplying straight across. 150 divided by 180. Let's reduce this fraction. Let's see. 30 goes into that 5 times. 30 goes into 180 6 times. 150 degrees is this many radians. Let's do another one. What is 225 degrees in radians? I don't know, but let's do it. 225. Oops. 225. We'll put it over 1. And we will multiply by pi over 180. We're going to multiply straight across. Not cross multiply, but multiply straight across. 225 pi divided by 180. And we're going to reduce that fraction. Now, I'm not going to lie to you. The calculator will do it for you. That's the lazy way out. I don't want to do that. Don't want to do that at all. Let's see. 5 goes into 180. I'm going to do this in my head. I'm going to do it. 5 goes into 180. Well, it's not in my head, is it? 36 times. You have 36 on the bottom. 5 goes into 225. I should know this. I totally should know this. 45 times. 45 pi over 36. By the way, I'm not done. This is not completely reduced. We're reducing fractions. You've been reducing fractions all your life. 9 goes into that. 9 goes into 45 5 times. 9 goes into 36 4 times. We're done. Okay? Alright, let's do a few that are not like that. Let's do a few where you go from radians to degrees. We're going to multiply by 180 over pi. So let's start with something like this. It'll say, what is 3 pi over 2 in degrees? Okay, well, let's multiply by 180 over pi. So 3 pi over 2 times 180 over pi. Okay, let's go for something obvious here. I would like to think that you noticed this already. Those pi's are going to divide out. While we're at it, let's start dividing some other things out too. 2 goes into 180 90 times. And now we're just going to multiply straight across. 3 times 90 is 270. Understood ones that are left, puts 1. So this is 270 degrees. 3 pi over 2 is equivalent to 270 degrees. Let's do another one. What is, I think of a good one, 5 pi over 4 in degrees? Okay, we're going to multiply by 180 over pi. So 5 pi over 4 times 180 over pi. Let's go for the obvious here. Those divide out. Let's keep reducing. 4 goes into that 45 times. 5 times 45 is 225. 225 degrees. There we go. Okay, below that, 9 through 20, there are some problems for you to work through. However, because of some cutting and pasting that sort of messed everything up, number 9 through 14 are exactly the same. So I'm going to mix this up a little bit. Let's rewrite 9 through 14. Okay, here we go. Number 9 is going to stay the same. Number 9 will stay at 255 degrees. Number 10, we'll let that one be 135 degrees. Number 11 is going to be 215 degrees. Number 12, 13, and 14. Just so we don't wind up doing the same problem 6 times. We'll let this one be 300 degrees. This will be 315 degrees. And this one will simply be, I think of a good one, 30 degrees. There we go. That's number 9 through 14. Number 15 through 20 is good. And there you go.